Hello everyone. Today we'll be talking about oncogenes and the role they play in cancer. Firstly, we need to know about proto-oncogenes. In the normal cell, proto-oncogenes help to regulate cell growth and division, which is also what is known as cell proliferation. So think of it like an on and off switch. Once the proto-oncogene becomes overexpressed, or rather the on and off switch becomes faulty, it becomes an oncogene. In this case, there is a rapid growth and division of cells. There are several ways a proto-oncogenes can become an oncogene, but there are three main pathways, which are point mutation, chromosome rearrangement, and gene amplification. In point mutation, this is simply a change in the coding of normal cells. When cells divide, they make their own DNA. A change such as addition or removal of a DNA code can cause an oncogene to be turned on. An example of this is the RAS gene, which can be found in pancreatic cancer or in the lung cancer. Now we have the chromosome rearrangement. In chromosome rearrangement, cells undergo translocation. A chromosome is a thread like structure in DNA. When it breaks, it can undergo translocation. During translocation, chromosomes break and attach to a different chromosome that leads to overexpression or an increased production of gene products, which means an on button can be left on. This occurs in Burkitt's lymphoma, that is, cancer of the lymphatic system. In Burkitt's lymphoma, DNA chromosomes 8 fuse with chromosome 14, which leads to the presence of semies oncogene. And lastly, we have gene amplification. This is simply when a proto-oncogene makes too many genes in the cell. For example, semicin oncogene mentioned in the previous slide is overproduced and becomes malignant. That is, it begins to spread in the body. Thank you.
Created using Powtoon.